please take it away.
Thank you. Good morning, everyone, or good evening if you're anywhere in the world. Um, Today I'm going to talk about small area population forecasts. It's actually a two classes thing. So today and next week I'll be talking about these methods. It's something that I've been studying since I entered the master's degree, so around 2020. And since it was the pandemic, I had a lot of time to spare. So I ended up studying a lot about this. So a couple of takeaways that I want you to leave this session with. Understand the intuition, inputs, and assumptions behind these practical methods for small area population forecasts. Learn the criteria to choose the most appropriate methods, and then see short runnable demonstrations for each method. So the idea here is that I'll go through some theoretical aspects of these methods, and then I'm going to go to a more practical one. So since I've been studying this for a long time, I have created two functions on R to help this process of population projection. But first things first, what is small area population forecasting? So we do understand that for large areas like large countries, Brazil, United States, even Tanzania, uh, it's very difficult to have census every year. This is not something that we have to do, nor we have the resources to do. Since they're too big, those countries are too big, what we usually do is every 5 or 10 years, we have a census and we then project population for these intermediate years. Meaning that in Brazil, we had a census in 2010 and then another one in 2022. Between those 2 years, we had 11 years that we didn't know any aspects of the population. So how do we uh, create public policies? How do we forecast the amount of uh, health facilities that we need? How many people have certain diseases? This is all something that is dependable on population. And since we don't have these populations counted every single year, we need to project. And this is a difference between forecasting and projection. What I'm going to explain is projection, but since most people seem to use these projections as forecasting, the term is just a mere detail. So a small area population forecast produces estimates of populations for small geographic units, usually for short or medium horizons, like municipalities, census tracts, neighborhoods. This is important because, as I said, we need to understand the population to be able to plan ahead for public policies and other health, education, and social security things stuff. One thing that is important is that this is very specific, and a small area population is not something that we usually do. And why not? It's very, very dependable on data. And we don't have this data. Large geographic units estimations are easy. We can do that simply looking at births. We can do that simply looking at deaths and some migration. We can do that by um, accounting how many people got a job, how many cars do we have. But that doesn't work for small cities or small areas. Let's think like a car. My dad has a car, but it's for the company he works for. So the car and he lives in Maringa, but the company is in another city. but the car is registered in another city. So it's within the same state. It doesn't matter. The state has that amount of people, but the city is different. And that can create some noise on planning public policies. Because if we're planning to use the number of cars registered in a city, it might not reflect the real numbers. Of course, it's very difficult for us to really create real numbers with those projections, but they're more close and to what reality really presents. So the idea here is to produce those estimates of population. This is very useful for spatial analysis, and that's why I wanted to give this class first, because since we're going to a spatial analysis 101 pretty soon, population is something that we're dependable of to do those spatial analysis. And we not always have those populations. So it is important for us um, as researchers to understand if it's possible or not to have those populations projected and which method is better for us. So the core purpose is, of course, to provide locally relevant population estimates that inform planning, public health, service delivery, and resource allocation, where national state projection are two cores. We have multiple families of forecasting or projection, cohort component, Hamilton-Perry, AIBI, mathematical. We have ARIMA, and no method is universal. We cannot expect that one method will work for all. And there is no best or worse. There is data and there is complexity. Since each family has its own data needs, and we want sometimes something that it's more stratified, then some methods won't work like others. One thing for sure that we have understood in these past years is that ARIMA, as you may know, is a trend analysis. It's not a good population estimate. We are not using ARIMA anymore. Why? It's statistical only. It's not based on demographics. It's based only on a trend that is statistically evaluated and estimated. And for a population dynamic, it's not always the best. The best thing for a population is to use population variables. So the ARIMA or other trend-specific models that do not use any population variables or demographics or do not imply Bayesian methods are not being used for small area population forecasting. I will not touch Bayesian at this time because Bayesian will be a little bit more difficult for us to understand since it depends on a lot of statistical understanding. And it's not something that we usually do for those small area population. So I'm going to start talking about a little bit of all of those families, and then I'm going to go to R to show you some possibilities. So first we have the mathematical methods. This is simple equations that project future populations using past trends. So as an example, like I said, Brazil had a census at 2010 and then another one in 2022. As we combine those two, using those past trends, I can project the population for the future. I can forecast. Of course, there are some limitations with that, especially when we think about the time length. So we had 12 years between those two censuses. So I'm able to project up to 12 years. More than that, it will extrapolate and then start to give some major errors and major estimations that won't be accurate because mathematical methods works in a functions. So we have arithmetic with a linear growth, as you can see in the first graph. So it only takes one point and then goes to another, like a linear trend, a linear growth. And this is like 1, 2, 3, 4, 5. It's not the best dynamic for population because it's not usually what happens. Population is not linear. We have the geometric, which is a compounded growth. And it's a parabol in the graph because it's not totally linear, but it still goes up or down. And it's a compound. So it goes from 2 to 4 to 6 to 8. It will grow exponentially, compounding. It also can be multiplying, like 2, 4, 8, 16. That is a little bit different, and we usually don't do that because it's very difficult for us to estimate those methods here. So the geometric, the compounded growth is best for us when we're trying to project those populations. I'm sorry with these mathematical methods, and I know it can be a little bit boring because there's a lot of formulas. But they're important because when we lack resources, when we lack um, specific data components, those are the ones that will be used because we need those populations. There is no other choice. We must have. If you go right now to the Brazilian Institute of Geographic and Statistics and try to get a projection for the population stratified by race, you won't find it. We don't have the population for stratified by race color in Brazil for any year there is not the census. Why? Because we don't do it. And it's important for us. So imagine that we're working with alcohol use disorders in indigenous populations in Brazil, in the Amazon, which we do. We have a lot of projects like this. But we can possibly know the indigenous population each year because we don't have this data. And since a lot of the fundamental data that we need to do more accurate is missing as well, what is left is this mathematical methods. Is the best one? No. Should be used all the time? Also no. But can it be used? Of course. Because we usually don't have those data. So those mathematical methods they are the easiest approach to what we may need at a short time because it's what's best at doing this projection. We don't need that much data. We don't use more than just 2 points of data. We just need the years and the population. That's all. So those two, arithmetic and geometric, are two good methods when you don't have any resources. They're really, really good. They will produce some errors. There's a fact. But when we lack everything, that's what's left. We also have the logistical one. I personally don't like this one because it implies that once it has a growth, it also has a plateau. So it will stop. And I don't like it not because it's wrong, because it is right um, for most areas. But the population dynamic, especially depending on what you're using as the parameters for years and population in the census, it will give you a inaccurate. That was proven in a Nigerian, I think. Yeah, Nigerian study, because Nigeria is now the third most populous country in the world, I think, the third or the fifth. And population dynamics depends on a lot of things. And this logistical, the saturation limit ends up putting the population into a stagnation that does not happen every time, especially for small cities. So we also have this logistical if we want something that we know that will saturate. But for mathematical methods, we prefer the arithmetic and the geometric ones. Am I talking too fast? Are you able to understand, comprehend, follow?
Yeah.
I'm following.
Perfect. If you have any questions, please let me know right away. I know it's very mathematical, statistical, but I promise you it gets better. Or not. I don't care. And then we go to the golden standard for population projection, which is the cohort component. And what is cohort component? It is based on demographics variables, births, deaths, and migration. Better saying, fertility, mortality, and migration net. And is usually stratified by sex and age because the population is aged forward using survival rates. What it means. So right now I have 27 years. I am 27 years old. I was thinking Portuguese. I'm 27 years old. In 5 years, I'll be 32. If I don't die. And that is a projection that the mathematical won't take into account because it's only doing a general population projection. But I'll be here, I hope. And I will have grown. I'll have aged. So am I be counted on 32 as 32 or 27? At 32. But will I be excluded today as I am 27? I was aged, so the population must be aged as well. So what these do is that it creates a forecast aging the population and seeing how the dynamics of births, deaths, and migration changes this aging. So for me, my life expectancy is around 80 years old because it's related to how most of the population die. That's the year that's the age where most of people die. But it's not sometimes what happens because I am 27. João Victor is 30? 29, 30.
30, unfortunately.
You're 30 and you're Brazilian, but you haven't been in Brazil, living in Brazil since 2023. So 3 years, almost 3 years. Oh, 3 years in February, right? So 27. At my age, João Vitor is not counted in the Brazilian population anymore. He's still Brazilian, don't get me wrong. But he's not Brazilian anymore. Not for public policies, not for healthcare planning, not for education status, because he migrated. So I'm losing the population, but not by death, but by migration. So with all of those understandings, the cohort component gives the golden standard because it takes into account how many births we have, how many deaths we have, and how the migration affects this population growth. We also tend to stratify by sex and age because the dynamics of sex and age are very different. So, and here is where we get to the strength. It's a scenario analysis. Like I said, you cannot use statistical or mathematical methods expecting it to be better than a demographics component. This is taking into account how the demographics exist right now. Of course, statistical and mathematicals are important because it's based on them that we have the demographics, but they don't tell the whole story. Furthermore, these are interpretable components. Everyone understands births, everyone understands death, and everyone understands migration. Not everyone understands the logistical. How can we say that we had a logistical growth if not everyone understands what a logistical is? Oh, it's just to explain. But here, if you say, okay, what changes in the population? People die, people birth. Not sure how to say this. People get birth and people migrate. People understand that. Very important. No, the cohort component does not extractify by class and ethnicity. It can, but it won't. Especially because we don't have the data. I'll talk about it a little bit later in the presentation, but we don't have the data to do that. For a couple of reasons. First is that race, ethnicity, is self-declared. And some people do not declare. Simple as that. They don't declare. Why? We can say about racism. This is something that people tend to rely on when they are asked about their race or ethnicity. So it can be if we have the data, but we usually don't have the data. That's the thing. We do have the births. We do have the deaths. We don't have migration. Migration is the bottleneck, and that leads me to limitations. We need migration for the cohort components. We cannot do anything for this golden standard without the migration. And migration is something that we don't have stratified by race or ethnicity, just because. The same goes for sexuality and gender identity. See that I use sex, not gender, because we don't have data on gender identity. We don't have on sexuality. So we can also project based on race, gender, sexuality. We only have sex and age. And we need migration. And we don't have it. So it became very hard to apply at very small scales because we need high quality data and we don't have it. If one municipality is able to have this data, then it might get a population projection that is more accurate. But most municipalities rely on the statistical bureau, and those bureaus usually don't do those kind of analysis. It means that we don't have any practical form to do that. We do. We actually do. There's two methods that we can apply to do something similar to the cohort component, but using less data. The first one is the AIBI. This is a replacement for the cohort components. And see, replacement not means identical. I'm not using any of the demographics here. But what I'm doing is I'm using a higher level population to project a small area population. So I'll project the population of Durham based on the population of Durham County. Because the higher level, the county, the state, usually the small area follows the higher area. So I can project the population for the Durham County based on North Carolina population. But for that, I need the higher level population. What happens if I don't? Then we go for a mix. We project the higher level population and then we project the small area based on a projection. Of course, it gets like a Frankenstein. We're going to project on top of projection on top of projection, but it's something that we sometimes must do. This method is very used by the Brazilian Institute of Geography and Statistics. Has been used since the 90s, I think, 1994, 7, something like that, because ensures consistency across geographic levels. We want the small areas to grow as much as the uh, higher level areas, bigger areas. As it uses linear trend according to higher level projection, negative population numbers can appear. Because what happens is sometimes a state decreases its population. And we have a population in a small area that is already small. So what will happen is that we'll have negative population numbers. So -1, -4. It's not something that happens in real life. For that, we need to round sometimes and then consider 0 because the projection is not completely reliable since you don't use the demographics, but it's the closest as we get. So very useful for total populations, underperforms for stratified groups. Can we use AI/BI to stratify for ethnicity and class? Yes. Will it be reliable? No. It will be valid, not very reliable, no. The best method we have now that replaces the cohort components and can be used for stratified is the Hamilton-Perry. So this goes basically very similar to what the mathematical methods do, but it uses those two senses that we have as different time points to project based on components that can be stratified. So it's more like a shortcut to cohort component. We don't need birth, death, or migration. These are implicit within the method. The calculation is a little bit complex, so that's why I didn't show you. But we need to have the population and then estimate the cohort change rate. So how the rates change within each subgroup, especially age and sex. And this one usually is useful for racial or class or schooling years of education projection because it does not need migration, which is the bottleneck. But it needs some enhancements. When we calculate raw Hamilton-Perry population, it's not enough in practice. We need spatial smoothing and a constraining. What that means, I live in a city called Maringá, and there's a city right next to us that is called Sarandi. And those two cities are conurbated. Is that how to say it? Like you can see the change from one city to another. There's no limit. Of course, there is a geographical limit and the administrative limit, but you can just cross a street and change municipalities and you'll never know because they are the same spatially. What happens is sometimes people live in Sarandi and works and do everything else in Maringá. So should we project the population based on Sarangi or Maringa? Because they're almost the same. Of course, Sarangi is way smaller, has like half the population. But is it, aren't they all Maringa citizens? Because most of them work in Maringa, most of them live in Maringa. They just sleep in Sarangi. So what we do is we do some spatial smoothing. So just like we do for public health research, that we use some base type of calculation, we also do those spatial smoothings here. And then some constraining, we put some limits on how this method can be, how much population it can add or decrease. So these are usual enhancements that need to be done for it to be a reliable source of population growth. So this is a conceptual table that shows each one and the data needs, the scale, and the population structure. So the mathematical is very low. We don't need that much data. It can be used at any scale, even large ones, but it should be used for population, total population. It's not the best for stratifying. The cohort component is the best for stratifying, works at large scale because of the high data needs. The AIBI is a low median data need and usually good for municipal scale. Not all small scales are good for AIBI. And it's also best for total population, not stratified. And then we have Hamilton-Perry, which is a low need at small scales and can be stratified. Good question. How does the AIBI methods account for and adjust for underlying socioeconomic difference, such divergent fertility rates, when projecting a larger area to a smaller geographic unit? It doesn't. It doesn't. What it does is that if the state is growing, the whole state is growing. So all the cities are growing. But what if one of them is decreasing? Of course, we can account for that, and we might be able to understand that decrease. But we can adjust for socioeconomic differences like fertility rates or births or deaths. The AIBI is not a method to that because it's based on data. It's not on demographics like the cohort component. So for us to be able to do this differences, we need to have good quality data, high quality data, and we don't. So those others that are not the cohort component won't get you those differences. And one thing is important, we can project, and something that we must understand when we're projecting population, it's not good to project differences that are related to things that can change very easily and is dependable public policies. What I mean is educational level. Educational level is something that is dependable on age, first of all, and public policies. So if a politician decides to increase the number of schools, that will have an impact that was not accounted for and can definitely underestimates or overestimates when we do those projections. Another thing is when we try to project by age or by sex, or by race, ethnicity, because those are innate characteristics. We can change. We can change sex, we can change age, and we can change race in a very simplistic way, of course. So those differences won't be necessarily good to be projected. The best thing is to get other types of data to do those projections, or to try to get to do another type of rate. So yeah, AIBI doesn't account for these socioeconomic differences. That's part of the problem. That's why small area projections are the ugly cousin of statistics. No one wants to work with that because there's no data. There's no such thing as high quality data for this. So it's something that usually people don't. The statistical bureaus will do it anyway. The Census Bureau will do it anyway. So why should I? But this is important for research because we need to do the most accurate possible. Okay. Questions on the theoretical part? Or something that you don't even understand, that you don't have any questions?
No, I think that this is great for the moment. On the theoretical, it's a lot of concepts to go through.
Yeah.
But in terms of like practical application for the theoretical, you mentioned that the Brazilian Institute of Geography uses the AIBI. Is that
The
right?
AIBI. Yes.
So when you like, if you go to the data source and you search for the population projections, I think that's the name of the data set, if I remember
Yeah.
correctly. That's the one that they are using. Um,
Not anymore. So
mm,
since we have the census of 2022, they updated the
oh, okay.
population using the cohort component because that's the golden
Mm,
standard. But if you go back to what they had prior, the outdated version, then that will be AIBI.
I see. And then for the AIBI and for the actually for the cohort, what they do is the census is that they do by the randomization process. They go like by census tracts, by zip codes, etc. They interview everyone
Yeah.
um, and get how many people in their houses, etc. to get actually the accurate population. Um, how much is it available for us as researchers? Like, tell us if someone here wants to do research on I don't know in the state in Brazil to see what is the HIV coverage, treatment coverage, how much granularity can they get from the data that is available, and how much granularity could we get if we used one of these methods for forecasting?
I mean, it depends on what type of granularity you want. My battery is running
Let's
low. Give me a
say,
second.
do you want to, yeah, if you want to plug it in, no worries. Take your time. Let's just wait a few minutes.